This is an AI. I'll call him Rookie for now. He is trying to learn how to fly this ship in zero gravity. He's not very good now, but he is about to get better. A lot better. I trained him using an action reward system, also called machine learning. But before we get to the training, I have to explain a few things. Rookie doesn't have complex commands. He doesn't know what fly forward means. He controls exactly those things. He can apply thrust forward and some small sideways or up-down thrust. He can rotate the pitch, the yaw, and the roll. And he can brake. That's it. No scripts for movement, no rules, just continuous inputs and their according score. Let me show you the training arena. Rookie spawns inside this arena. There are a destination sphere and a direction that Rookie has to face before stopping. And there are asteroids placed all around it. Everything here is randomly placed in each try that Rookie has to make. There's also a time limit to reach the destination, and once reached, he will get a new time limit to stop inside the sphere, without leaving it again. Crashing into an asteroid is a failure. Leaving the arena is a failure. Running out of time is a failure. Leaving the destination sphere after entering it is a failure. Stopping inside the sphere without leaving it is the only way to succeed. Facing towards the target is not a success condition, but will increase the final score. Let me use this visibility panel to show you exactly what Rookie can see. Well, he can't really see, but some of the numbers he is monitoring from the environment can be represented visually. There is the big blue sphere, which is the arena boundary. The asteroids are actually invisible to Rookie. What he is seeing is this white sphere, which is the collision boundary of the asteroid. Then there are those red spheres surrounding the asteroids. They are proximity fields. They tell Rookie that he's inside a danger zone, close to something that could hurt him. He can also track the 3 closest dangers and the location of the destination sphere along with the direction he has to face on stop. With such a complex training, I had to understand what Rookie was doing and the rewards he was getting on each turn. So, I created some panels to monitor his progress. The training monitor shows how many episodes were completed so far, how many successes and failures, and each kind of failure. Then we have the agent panel, showing the state of the agent, the roll error and pitch error in relation with the horizontal plane, the direction alignment, the speed and angular velocities, and some information about the closest proximity danger, an asteroid in this case. You might have already noticed the tracking lines, the green one towards the destination, and the red ones towards the closest 3 asteroids. This one line, which is thicker, is pointing which of the 3 asteroids is the closest one. This panel shows what Rookie is experiencing right now. This means that this is how I teach him. I translate everything happening into numbers. He will observe the states you've seen previously: velocity, distance to asteroids or to destination, the orientation, the roll, and so on. And he will apply inputs. Those inputs will create new states which will translate to new rewards or penalties. By doing this over and over again, Rookie will learn which are the most likely inputs to generate the best rewards for that specific situation. The action calculations have a frame-by-frame update rate. So Rookie analyzes the situation frame by frame and applies the best actions he can think of. This process is called Proximal Policy Optimization, or PPO. It's the algorithm doing the magic behind the scenes, turning trial and error into learned behavior. If you're curious, there are plenty of materials about it online. But for me, it's enough to know that it works. Let's get back to the panel, which is breaking down all scores. While flying to the destination, Rookie will experience the following rewards and penalties. The distance penalty or reward starts on 0 and will increase to positive values the closer Rookie gets to the destination, or decrease if he gets further away. Facing rewards facing toward the destination. Looking away means penalties. The facing away penalty is also doubled up with this specific away penalty. The roll rewards him for keeping the ship level with wings parallel to the horizontal plane, oriented upwards. I want Rookie to always have a good roll, so I reward him each frame of holding a good roll and penalize him for each frame holding a bad roll. The flight reward is also based on this roll. It's basically a quality bonus for combining good roll alignment with good heading and speed. And to emphasize the importance of moving there fast, I added a separate velocity reward for moving fast toward the target. This will turn to a penalty if the velocity vector is pointed away from the target. Then there is also a retreat-specific penalty for moving away from the destination, to emphasize that this is a bad behavior. For the encountered asteroids, the proximity will penalize getting too close to them while facing them. The closer and more direct the approach, the stronger the penalty. Sitting in the proximity field is possible, however, if we orient away from the asteroid to 70% or less. Rookie will also receive the evasion reward for facing away from the asteroid while it's in its proximity field. This will help him discover the next reward, the orbit reward. This is given for flying past asteroids while maintaining an orientation greater than 60% toward the destination, and the asteroid at around 50% orientation. So Rookie must fly tangential to the asteroid as much as possible to maximize the reward, but he must also be slightly headed towards the destination. When Rookie reaches the destination, he gets a one-time bonus, the entry bonus. The cleaner the entry, lower speed, better alignment, the bigger the bonus. This will also be turned to a penalty in case of bad entries. I need Rookie to really understand that the orientation on arrival is as important as stopping inside the sphere. Now, what are those delta rewards and penalties? To make it simple, it's the bad or good difference between the current state and the previous state. Consider roll, for example, and let's say that Rookie is entering the sphere with a specific roll. If Rookie rolls so that he aligns the ship better to the horizontal plane, then that is a positive difference. If he rolls to an even worse position, he will get that difference as a penalty. The same delta system is used for pitch, distance between sphere boundary and center, for velocity, and for the stopping orientation, or arrow as I called it. At the end of the episode, Rookie will also get a final reward based on the same deltas calculated in relation to the desired perfect stopping position. This will emphasize in training that stopping with a good orientation will increase the final reward. And finally, the training consists of a very important permanent penalty, the time penalty. This will be an action from start to end, and it will simply add negative score for each frame spent without success, so Rookie does not waste the time wandering around to collect orbiting bonuses before reaching the destination. Breaking inside the destination sphere will also reward Rookie to encourage him to discover the need to stop in order to achieve success. Timeouts and other kind of episode failures will just add a very consistent negative value to the final score, while succeeding will add an even more consistent positive value to it. Before I race Rookie to the destination, just to test his skills, I want you to watch some of the training episodes. This way you can see how Rookie is learning and how the rewards shape his behavior. I wish I could show you all of them, but training this complex takes sometimes hundreds of thousands of episodes, over around 50 to 100 hours spent during multiple days of training. During this time, I had to periodically come by and check how Rookie was doing, and if I found unwanted behaviors, I had to observe the rewards and understand which were active during those unwanted behaviors. Then, I had to apply fixes and start again, usually starting from scratch. It really depends how far you want to go and how accurate you want the AI to be. Getting the basic actions right and seeing some successful episodes can start happening in around 10,000 tries, but mastering the rewards will take longer the more accurate you get. What I mean by this is that improving the success rate from 90 to 95% can take as long as it took to get it from 0 to 90%, and most of the times, it's just not worth it. After around 2,000 episodes, Rookie started to slowly understand that he had to fly to the destination and avoid obstacles, even if he was still very bad at it and was still flying at low speed. It was good enough, however, that some version of Rookie, in one of the other hidden scenes, managed to get an accidental early success. After around 5,000 episodes, the navigation was clearly improving, but I noticed that Rookie was already learning some reward exploit. Facing and velocity rewards were too high, so He learned how to drift around the destination to keep gathering score. And because he found this exploit, he was trying to improve it instead of exploring new options, such as entering the destination. As the navigation behavior was improving consistently, I decided to let Rookie enjoy his drifts for a while. This behavior can be corrected later by tuning the rewards. Changing the rewards will teach Rookie new behaviors. If you look closely, the facing and velocity rewards are really high. They add around 6,000 score, while all other rewards sum up just around 300 points. This is not a mistake. It's part of the process and ended up like this because, in the beginning, the facing reward needed to have the same weight as all the penalties, so the agent would actually feel that reward and start moving while facing the target. After the agent starts learning specific behaviors, the rewards can get very disproportionate and need rebalancing to allow further improvement. During training, I had to be careful to make the most significant rewards or penalties dominant, but not too high compared to everything else, and slowly push Rookie towards the desired skills. At around 10,000 episodes, I reduced the facing and velocity rewards and increased the evasion and orbit rewards, expecting Rookie to start getting even better at avoiding obstacles. I also increased the time penalty enough so that orbiting the destination would no longer be profitable. This way, Rookie would be forced to enter the destination to get the entry bonus. When the algorithm can no longer feel the rewards it was used to get, it will start to explore new inputs, and by doing this, it will eventually discover the sphere entry bonus. I have to make a big jump in the training process, a jump of a few tens of thousands of episodes, to show you one of the very good ones. I'll let it play at normal speed. At this stage, Rookie was flying at over 100 meters per second, which is a high speed for him, as the maximum speed he can reach is around 120 meters per second. Notice that all the rewards have a good scale compared to the others. This stage of training was part of the final fine-tuning, which is why it was really important to have well-scaled rewards. Rookie was already succeeding 9 out of 10 episodes and could already navigate through complex clusters of asteroids, as you can see here. It's really interesting to watch him take some time to feel the environment before applying actions. This mostly happens when Rookie is facing unencountered situations. At the end of this impressive run, he also stopped with a really good position and orientation, getting a close to perfect stop. Now I'm going to race Rookie to destination for 10 episodes. I'm also going to try to get the best score possible. The rules are simple. Success is achieved by the first to stop inside the destination sphere. If any of us fails the episode, then the other automatically wins it. know you might think some situations were not fair in this race, but I did this just to demonstrate the capabilities of the system compared to a human. And Rookie could be trained to get a lot better at this. I tested Rookie, and I was pleased with the results, and deciding when to stop is something really important to understand in machine learning. The next arena is already built, and it's built for competition. This time, I am creating a fair race, and Rookie will know that he is racing, not just navigating. A dense asteroid field, multiple checkpoints, and a timer. Next time Rookie will not race me, he will race other versions of himself. Generations of code, fighting for the optimal path. The early results are ruthless and efficient, and they're also a lot of fun. If you want to watch Rookie evolve, subscribe. The training continues.